Welcome to West Virginia, where things are gorgeous. Okay, are you ready for joke of the day? I know you are, because we all love joke of the day. It's the best part of the day. So, what rock group has 4 men that don't sing? Rock group, 4 men that don't sing. Mount Rushmore. Okay, well, Mount Rushmore is not in West Virginia. Mount Rushmore is out in South Dakota, but that's all right. Let's rock our way into factoring difference of squares. So when you factor difference of squares, first we need to recall what it means whenever I've got this labeled incorrectly. Here we go. An x plus 3 times an x minus 3. Now you know when you see something like that, you know you're going to FOIL or extend a distributive property. And I'm going to do x times x is x squared, x times negative 3 is a negative 3x, and 3 times x is a positive 3x, and then 3 times negative 3 is a negative 9. You also know that when you combine up these like terms, they are going to cancel out because they have opposite signs, and I'm only left with an x squared minus 9. This is a difference of squares. Difference because of the minus sign. Squares because this is a squared term. The square root of this is simply an x, and the square root of this is a 3. That's why this is called a difference of squares. So what that tells me is whenever I have a difference of squares like this generalization here, a squared minus b squared, I can factor it into a pattern. That pattern is take the square root of that first term and put it into the front 2 slots. Take the square root of the back term and put it into the back 2 slots and simply change the signs between them. That's the pattern that we can use to factor a difference of squares. So if I want to use that pattern, then what I'll do is I'll say the square root of a squared is a, put it in the front slots. The square root of b squared is b, put it in the back slots, and simply change up the sign that's between the two. However, if you're anything like me, I don't really want to memorize more than I have to, because now I'm getting old and I can't memorize like I used to. I used to be amazing at memorization. It's not there like it used to be. So to avoid the memorization, let's go back to what we know about factoring. Remember, back sign will always tell you about those signs, whether they're the same or opposite. If the back sign's a minus, now granted there's only one sign here, but if it is only one sign, then it is the back sign. So this is going to tell me I have opposite signs. One's a plus, one's a minus. Now once that has been established, then all I have to do is say, well, I'm going to split this up into the front 2 slots, and the only way to split up an a squared is an a and an a. The only way to split up a b squared into the back 2 slots is a b and a b. So what I'm pointing out to you is, sure, you can memorize the pattern and put the pattern in there, or you can go back to the old rules of factoring that we've been using all along. So, let's take a look at some examples here. Now remember, always look first to see if there's something common you can divide out before you do anything else. There's nothing common here, so I'm going to go ahead and head for that double parentheses. And once again, I can recognize, oh, difference of squares, the square root of that is y, the square root of this is 5. And I can follow that pattern. Or I can say, this back sign's a minus, and that tells me that my signs are going to be different. I'm going to split this into the front 2 slots, and the only way to split up a y squared is a y and a y. I'm going to split this into the back 2 slots. Now I could split it as a 25 and a 1 or a 5 and a 5, but 9 times out of 10, if it will split evenly like this, that's how it's going to split. You can always check this, FOIL, but remember, I don't need to worry about these front 2. I guarantee it's a y squared. I don't need to worry about the back 2. I guarantee that's a minus 25. Outsides and insides is what I'm worried about. Out here, I get a negative 5y. In here, I get a positive 5y. And those two cancel, and I need them to cancel because I don't have a middle term in there. So I know that this is, in fact, the correct way to factor it. And it does follow the pattern that we just discussed. That I'll take the square root and put it into the front slots, take the square root and put it in the back slots, and simply change the sign between them. Now, let's take a look at this example. Once again, always look first. Is there something common that I can divide out? No. So I'm headed for this double parentheses. And once again, I can follow the pattern if I'd like, or I can say, this back sign here is telling me opposite signs. I'm going to split this into the front two slots. Now I could split it as a 4 and a 1 or a 2 and a 2, but if it splits evenly, 9 times out of 10, that's how it's going to go. Plus, I know that 2 is the square root of this. I know that I can split this up as an a and an a. In other words, the square root of a squared is a, but the square root of 9 is 3. So I could split that up as a 9 and a 1 or a 3 and a 3, but again, 9 times out of 10, if it splits evenly, that's how it's going to go. So I know that 2 times 2 is 4. I know that 3a times negative 3a is a negative 9a squared. It's out here with the negative 6a, and in here with the positive 6a that I'm worried about, and those two do in fact cancel. I needed them to because I don't have a middle term. So I know that this is in fact the correct way to factor it. Okay, let's take a look at just 2 more examples to make sure that we are very good at this and nothing shocks us. So once again, is there anything common that I can divide out? Nope. So I'm headed for this double parentheses, and I can utilize that pattern saying, well, the square root of 4 is 2, the square root of x squared is x, the square root of 49 is 7, and the square root of y squared is y. Or I can say, well, I know that this sign here is telling me I've got opposite signs. I'm going to split this up. Now, splitting up an x squared, only an x and an x. It's the only way to do it. But that 4 could be a 4 and a 1 or a 2 and a 2. I'm going to go with that 2 and the 2 because 9 times out of 10, that's how it will go if it factors evenly. Plus, there's no middle term in here. When there's no middle term, I'm thinking, they're going to split evenly. So that means I'm going to do my 7y here and my 7y here. Guaranteed that 2x times 2x is 4x squared. Guaranteed 7y times 7y is 49y squared. And on the outside, I get a negative 14xy. And on the inside, I get a positive 14xy. Sure enough, those cancel like they needed to. There's no middle term. I needed that to happen. So this is, in fact, the correct way to factor it. All right, last one. Anything common that I can divide out? It feels like there is, but remember, this is only divisible by an 11 because 11 times 11 is 121. And here, 6 times 6 will give me 36. So I'm thinking, I bet that's how this is going to go because it will split evenly. So I'm going to try my 6x and my 6x. I'm going to try my 11y and my 11y. And this back sign tells me opposite signs. So now 6x times 6x is 36x squared. 11y times 11y is 121y squared. And out here I will get a negative 66xy. And in here I'll get a positive 66xy. And sure enough, they cancel like I needed them to. There's no middle term. I needed that to happen. So that is in fact the correct way to factor it. So difference of squares, like I said, you could memorize the pattern if you really want to. But the easiest thing to do is just simply to say, okay, this is going to tell me opposite signs. Split that evenly here and split that evenly here, and that's going to be your difference of squares. I hope that helps. Have a great day.